Theorem 4. That's what we're going to go through in this tutorial. We're going to mention all that you need to know and also a few other variations of how this can pop up. Hi guys, Lever here from Bright Young Brains. So with Theorem 4, we want to keep in mind, in a sketch that is mapped out in this manner, A will be equal to B if they are both subtended by the same arc or the same chord. So if we write that out, this is what we could write out. Angles subtended by the same arc or chord are equal. So you may be thinking here that the keyword is same. So the blunt answer is no. So the reason why I'm saying that is angles subtended by the same chord or arc will be equal. However, angles subtended by arcs or chords of the same length will be equal to each other. In other words, if we had another circle like this one, as long as these two chords are equal to each other, automatically angle A will be equal to angle B, because this theorem, angles subtended by chords or arcs of the same length will be equal to each other as well. So here it can be the exact same arc or the exact same length, or it can be arcs or chords where the size is equal to each other. So you see two different triangles, but then these chords are equal to each other, so this theorem also still stands. So if we write that out, we would just specify at the end that we are referring to chords where the length is equal and that they are not necessarily the exact same line. So the converse of Theorem 4 basically states that, say the circle was not there, right? Like this. The converse basically states that as long as you have a line that is subtending two angles, or rather a line segment that is subtending two angles, as long as those two angles are equal to each other, it means that you are able to draw a circle around 1, 2, 3, 4 of those points there. So in simple words, as long as you have an angle that is subtended by this line here, and then another angle being subtended by the exact same line, it means that as long as these two are equal, you are able to draw a circle around these 4 points there. There we go. If a line segment subtends equal angles at two other points, this point and that point, then these 4 points lie on the circumference of a circle. So that's what you want to keep in mind about the converse of Theorem 4. Theorem 4, Corollary. So what this means is, with Theorem 4, you want to keep in mind that we also need to remember that as long as you have a shape where you have a circle, and then in that circle you have two triangles where two angles that are coming from the center of your circle are being subtended by chords of the same length. As long as this scenario is playing out, it means that those two angles will be equal to each other. So what we will have been given here is just a plain sketch, whatever Euclidean geometry sketch that you would have been given. As long as you see that you have two angles where they are both coming from the center of the circle, as long as those two angles are subtended by chords that are equal in length, then it means that those two angles themselves are equal to each other. So this is one of those rare things that you will hardly see. However, you don't wanna not know it because if it does pop out, then this is what you wanna keep in mind, and then this will help you whenever you're working on specific Euclidean geometry questions. So with Euclidean geometry, obviously we know with some of the questions that you get, they're not always plain and friendly and all that. So when you're working on actual Euclidean geometry questions and you get super stuck, then you can just send me a DM on IG and then we'll definitely be able to help you out on that. So what I actually do is, when people send me questions on stuff that they're working on, I quickly make a mini video on a paper, and then I upload it onto my IG math page, which is called Zero Aesthetics, Just Mathematics. So yeah, if you just want some extra help and stuff like that, that is available for you to have a look at.